Can't win them all. Okay. So as we keep going through these, we're going to be looking at different types of ways that the exponent is going to be the unknown. Okay? If the exponent is the unknown, you're probably not using logs. Okay? You don't need them. You can just figure it out. So today we're going to be looking at growth and decay. Now, growth, most people understand. They just think, hey, it's going up and up and up. Decay does not have to be something rotting in the bush or that thing at the back of your fridge. Okay? Decay actually specifically means it is decreasing at an exponential rate. Okay? Now, when something increases, it means you keep multiplying it by a number greater than 1 every time. If you multiply something by 1 every time, it doesn't change. So it's got to be a little bigger than 1 if it is going to increase. If it is going to start decreasing, it must be less than 1. Okay? So the number that is making this either growing or decaying is the b. Now the b, like I just said, if it is greater than 1, see it doesn't say greater or equal to, if it is greater than 1, it is called a growth function. If it is between 0 and 1, it is a decay. Okay? But both of them, the b must always be what is remaining every time. Okay? So if I throw you this example, it is the, let's say organism or whatever is decaying at 10% every year. Or we are losing, 10% of our fish population in this pond every year. You do not multiply by 0.1. You multiply by how many we will have next year. And we will have 0.9 or 90%. We will always be keeping 90%. Okay? So the question you should always be asked is, I will have what percent next? Okay? Not what am I losing? Okay? So it's kind of that glass half full, half empty, right? We are never going to talk about how empty it is getting. We will always talk, well, how much is still in there? Okay? So we're going to be extremely positive. So if you lose 2% every year, your B is going to be 98. Why? Because I will have 98% of what I had last year. But you can see how it is going to go down. Okay? The diploma will try and see, do you know that? When they say, hey, you know what? They don't always ask for an answer. They'll just say, what would the formula look like if you had population of fish in a pond, they're decaying by 5% every year for, after 20 years, what would be the population? And they may just want the formula. And of course, 0.05 is going to be one of the selections. Okay? They want you to know that. It is so, that one just, you gravitate towards that one. You see a 0.05, they got a 0.05, right? And of course, like I said, that is why this diploma has the greatest standard deviation of all the diplomas. Okay? Because if you haven't been showing up for class, you're going to grab that one. It makes sense, kind of. Right? But we always want to be thinking, I will have how much next. Okay? Not how much have I lost. I need to take the loss to find out how much I have. Okay? So keep that in mind and see if I'm being consistent when I'm going through these. Okay? Again, let's try and keep the notes as short as possible so we... let's go to the next example, okay? So here we go. We got the fish example right here. The number of fish in a lake is decreasing by 5% each year as a result of overfishing. If the number of fish present is an exponential function, state the base exponential function. Okay? State the base. State the b. Okay? So how much will I have next year? 95%. So you can go 1 minus 0.05, which is 0.95. That is my b value. Okay? So one more thing I would write on a study sheet, because you will forget that in 5 months. Always put what you will have, not what you have lost. Example, decreased by 0.05, the b would be 0.95. That is such a nice thing to have 3 months from now. You come back and look at that. Okay? Like, are you guys understanding how much you're forgetting over a weekend? So keep that in mind as you're doing your study sheet. Are you making it for yourself if you totally forgot the entire unit? Now, it says write an equation to represent the number of fish present after t years. Use n naught to represent the initial population, or n. Okay, that's what the 0 means naught. Okay, and nt to represent the final population. Now, nt means the number at that time that you're going to give, right? So we're going to start with, well, this is what I'm looking for, nt. Well, that equals n naught times my b, which is 0.95, to the t. T stands for time. Okay. Yeah, I'm just being really specific about my b, I guess. Now, let's do a practical problem. There's 2,500 fish present in 2012. How many would there be in 2017? Okay, so this is n. What would be the time? 5 years. Good. So it's 5, and that would equal. So n5. Look, I'm not multiplying by 5. Do you get that? Keep it low. It's a subscript because it's nt, n at t time. Not multiplied. That's an actual variable. So n at 5 years. The number of fish at 5 years. Again, why is math so confusing? Because it is so concentrated, okay? It is such an efficient language. This, to say it, would be the number of fish in 5 years. That's what n5 means, okay? Now, I'm starting with 2,500 fish. My b is 0.95 for 5 years. Okay? Put that in your calculator. I think most of you would know how to do that. Be 1,934 fish. Okay? Now, how many years to the nearest tenth would it take for the fish population to reduce to half of the number in 2012? Okay? Now, half is 50%, right? 0.5. So then, what would you call like the amount of fish now? Like if I was going to call n at whatever time, if I'm going to call this 0.5, how many fish do I have now? Or 100%. Okay, I have 100% of my fish now. When do I have 50%? Okay, or we use 1 and 0.5. Okay, so remember, now we have 100%. Okay, then is going to be 50%. All I did was move my decimal over 2, because you can't deal with percent. You always have to deal with decimals. Okay, I have 0.95 to the t. We can divide the 1 out. That's pretty easy. So how would you find out what t is? Log it, right? So that would be log, what's the base? 0.95 to the 0.5 equals t. Okay, try it out. Yep. Because d is not the same as c. C, if you tell us the exact amount of fish, d says how much to half. Okay, so you could do that. Yeah, you could put 2,500 and then 1,250 as your, but as soon as you do that first calculation, you will get 0.5. Okay, so I'm good with that. If you want to, you could have used 2,500 here and 1,250 here. Okay, that makes sense? You could have used that. So we could have had 1,250 here and 2,500. As soon as you did your first calculation, you would get 0.5 anyway. Okay, which is cool, right? If you thought about it both ways and you both get the same answer, that's awesome. That's kind of a good feeling. Okay, how many years? 13.5. Now, can you just give me the actual number? 13.5, 1, 3, 4, dot, dot, dot. Now, here's the argument. In 13.5 years, would it be half? No, it wouldn't. So there would be a stronger argument to the nearest year. When would it happen? Would be 13.6. Now the book says 13.5 as the final answer because it used rounding rules, right? It makes sense. 0.51. What do we always learn? If it's 0, 1, 2, 3, 4, leave it alone, right? But if we back this up, and if I put 13.5 in here, okay, I get, what is it like? 1251, I think. Yeah, I get 12, actually get 1250.8. That's not half. Okay, so when is the actual year there's half? I would argue that 13.6 would be when it has got to half. Because it hasn't got to half in 13.5. Okay? But the book says 13.5. Now, I'll tell you, on my exam, there will be no confusion. Okay? Also, if it was a multiple choice, I wouldn't have 13.5 and 13.6, unless, of course, I was really testing that. But just make sure that the one that you choose, you have a very good argument for. Okay? Like Reagan has right now. Yes? Closer to half, but right. Right. So 13.6, I would, well, here's kind of a better example. That what if I had like a really, really dangerous gas in a room and you can't go back until it's at 5%? Would you go when it's 5.1%? No. You want to probably, but 4.9 you're okay with, right? So at what time to the nearest tenth would it be safe to go in? Right? You would go so it's 4.9. Okay? So this one's kind of saying, when would I for sure have at least half? The 13.6 I would have a better argument for. 13.5, there's more than half in there. Right? So, but the ones that I would have on my exam, there would be a clear argument. Okay? Okay. Now, this one here, like I said, there's going to be one question on like 3-4 days of what we're doing today. One question. And it could be something just like this one, because this one is off a diploma. Okay? So the intensity, I naught, of a light force is reduced to I after passing through d meters of fog. According to the formula, I equals I naught e to the negative 0.1 d. At what distance to the nearest hundredth of a meter will the intensity be reduced to 1/4 of its original value? Now, the thing that is probably the most discerning, or that people don't like about this, is you didn't give me any numbers. You just gave me a formula and a bunch of words, right? So that's why this one is probably more difficult than any other one, because they don't give you nice little numbers to get in. Oh, look, I just have to look for D, right? This one you have to actually really think about all the numbers. And here's, do we get used to using E? E is not a variable. Pi is not a variable. They are actual numbers, okay? So when you get to the diploma, you have to know that, right? You have to know that E is an actual number on your calculator. Now, can I put anything in here? Okay, where? Who's what? Okay, or I could do this, right? Okay. What's a good way to solve for D? Log both. It would change. We could go to log, right? Because E is a number. You could also log E to both sides. That's another. We haven't been doing that a lot, so I'm actually going to do that as another option. But I could, if I log E here and log E here, what's my point? Why? Why would I do that? How have I made my life easier? Because I got to log E to the E, which is 1, right? And that third level comes down. So this is log E 1/4 equals negative 0.1 D. So to actually solve this, I would have log E 1/4 all over negative 0.12 equals D. Okay? And sometimes that's all they ask for. What would be the formula to figure out D meters? And that's it. Okay? And if you put that into your calculator, how would you put that in? A big bracket, log 1/4 divided by log E. Okay, shut that bracket. And then another big bracket, right? Because I want all of the top now divided by negative 0.12. And it's like 11.55 something. So technically, it wouldn't be at 1/4 at 11.55. I would say technically 11.56 meters. Does that make sense? Yep. Can't hear you. Yep, because log E is the same thing as ln. Yep. Okay, now we're going to talk about half-life, doubling life, tripling life, that sort of thing. It gets a little bit more complex, but not that much more. What's that? Oh, what? Okay. Now, why is half-life so important? Because the way that something halves or something doubles is extremely unique to that substance. When they take a biopsy, if you have cancer, if they take a biopsy, they're taking it to find out what type of cancer it is. They don't look under a microscope and see that it, it's got, a little tail on it here and this, that's that type of cancer. That's not how they figure it out. What they do So they put it in a petri dish. The next day, they look at it, and they find its doubling time. After they find this doubling time, they go to a database, and it'll tell exactly what cancer it is because of the doubling time. Okay? No two cancers, no two organisms, no two different things in this world have the same doubling time or half-life. Okay? If it's decaying, it'll have a half-life or doubling time. That's how they find out what type of cancer it is, and that's how they do their treatment. Okay? So this is extremely relevant to anyone, that's in biology or whatever, or they are in the lab working with different types of diseases. They will be looking for the half-life. Now, the formula that we will be using is, next page, right here. This is the formula. So we want to talk about, now this is your, final amount. This is your initial. Amount. Now C will be your doubling, tripling, half. Like if it's a half-life, you're going to put a half in there if it's halving every 3 hours, okay? So that's what C will always be. It's a constant. So if it's doubling, you'll put a 2 there. If it is quartering, it will have a 1/4 there. Half and 2 are the most common. Now, this is the other one that is you got to worry about. That is P. That stands for the period. At what? That is, how often does it double? So these two make a sentence together. It doubles every 3 hours. That means 2 and 3. It's halving every 5 hours. Half and a 5. The T is how long it has been doing it. Okay? So this is the time it's been going. Okay? So CP will be the unique doubling time, half time, tripling time of that substance, C and P. T is how long it's been in the petri dish, or how long it's been in the bush, rotting. Okay? That's what T is. No question? The final amount and initial amount. Okay, so the best way to get these is to do a few of them. Okay, so a patient is feeling ill. Had a sample of bacteria taken from her throat. I shouldn't hear any voices because I'm talking, right? The sample contained 387 cells. 24 hours later, the sample was recounted and found 8,012 cells, okay? So what I'm trying to tell you is people don't sit there and look at it, hey, it doubled, okay? They don't do that, okay? They don't have the time. What they will do is they will have an exact time, they will count how many, okay? With that exact time, count how many, they will figure out the half-life, and therefore go to a database and know exactly which bacteria it is, and here's the antibiotic we would use, okay? So, the formula is always a nice thing to get down. We have A equals A naught times the C to the T over P. So, the final amount was 8,012. The initial amount was 387. We are looking for the doubling period. So the doubling period. Okay, do you see how these go together? This is the doubling period. That's actually how you would say it. If they told me the doubling period was 8 years, I'd have a 2-8 there. And on top of it is the time, and the time was 24. Okay, so what's confusing about this formula, what you really got to keep straight, is the P and the T. The P is linked to the C, meaning if it halves at this time, or this period. Okay, 24 is actually the time it was in the dish, or whatever. So, first thing you want to do, divide by 387, right? And I'm not even going to do any calculations. I am just going to write it as a fraction. Okay, so 8,012 over 387 equals 2 to the 24 over P. Now, you can log it, right? So this would be log. The base is 2. 12 over 387 equals 24 over P. Now, without going to our calculator, what would you do next? Yes, okay. Remember, this is all over 1, okay? This is a ratio equaling a ratio, so we can always take the escalator, as long as it's just one fraction equal one fraction. So my final answer actually would be P equals 24 divided by log 2 of 8,012 over 387. So that would probably be, I've seen this more than just the final answer. This is the exact answer. This is exact, not approximate. Approximate would be if you put it into your calculator now. And if you put it into your calculator, you get P to equal, it's 45.715. Okay, yep. Oh, sorry. I'm looking at the wrong question. Yes, it's 5 point, just let me get this down, 5.4897. Okay, sorry, go. Yep, yes, you could. Right. Okay, and you have to get used to this, right? You actually have to get used to leaving it alone and just doing all of the driving and moving stuff. So the period would be 5.5 hours. Okay, so there is only one bacteria that doubles every 5. Now, obviously, they're going to keep it to probably like 10 decimal places, right? Because 2 bacteria may be so close that 5.5 is rounding too much. But it is pretty neat. So the characteristic of pretty well every disease, every thing that when they do take a biopsy or take a sample, they swab your throat. If you've ever had a strep throat, they swab your throat with a Q-tip, and they rub it on a petri dish, and they figure out what it is from that. Okay, when I used to teach science, math science in junior high. And, we had all of our petri dishes with like the jelly in it, and everybody got to take their Q-tip and go somewhere and just swab it and then come back, and then we left it in a dark closet, and then like a week later we took them out, then you put them on the overhead projector and you got to see these things up on the, there's some pretty, you know what the worst of the entire school was? A thing that was like almost blowing the lid off of the petri dish. And you know the funniest thing was the one that was did the least was someone swabbed like a urinal, put in there. It was the least because it must have had bleach or something on it. But the worst was like the gym mats. You know the wrestling mats? Yeah, so don't lick them. Okay, that's just a little advice for today. Okay, very applicable to what we're doing right now because you'll probably be getting another swab a little later. Okay. Okay, another cool little day in history. 1986. What year were you guys born? 96? Oh, yeah. So some of you may be the product of this, actually. Because in 1986, and this might explain a couple of you guys, actually. In 1986, there was a nuclear accident in Chernobyl that contaminated the atmosphere with quantities of radioactive iodine. Okay? So this was a pretty scary day. And this is why nuclear reactors are as controversial as they are, because nuclear reactors are pretty safe depending on who's running them, okay, or what kind of upkeep they have. So you put a lot of trust into a country that has a radioactive nuclear reactor, because if they're not taking care of it, it blows up. Like we're all sharing the same atmosphere, right? So it's kind of like having a peeing section in a hot tub, okay? You know, that's, yeah. Well, in restaurants, you used to have like a smoking section, right? And if you were like the next table to the smoking section, you weren't in the non-smoking section, really, okay? So it's like because you're all sharing the same air. So that is why they have taken smoking out of restaurants, because people that are not smoking are saying, hey, how come I have to smoke? I don't want to, okay? And that's where someone drew that analogy, like having a smoking section in a restaurant is like having a peeing section in a hot tub, okay? I think you can use your imagination. So, in 1986, Chernobyl had a huge meltdown, and so if there's radioactive iodine-131, if the half-life is 8.1 days, determine the number of days for the nearest day it took to the level of radiation to reduce to 2% of its original level, okay? So if it was known that it's very unsafe to go back until it's below 2%, there's a case where when it's 2.1, I probably wouldn't head back. Maybe wait a couple more days. We've already waited out long enough. Let's wait a couple more days, okay? And I watched a show recently where they went back to there, and they actually had the like nuclear detectors. The needle still goes nuts, and they're actually driving by the town, not even just at the reactor. Yeah. Yeah, it's not good. Okay, and then not to mention all the people, right? So yeah, it was not a good day in history. The world was pretty, and then what do, right? Like, so now you have to, unless you want it over here, like they had to encase that thing in concrete, right? So, I mean, maybe they're like, well, we don't have the money to do that. So that's where the rest of the world says, well, I guess we better get it done. I mean, we can't just sit there and go, hey, well, that's your reactor. You better put it in concrete, right? So, you know, the world had to kind of get together and figure that one out. So, what would be my now? Okay, my A, because it's A naught times c to the t over p. So what do I know? I don't know t. Well, tell me everything else. P is 8.1. Okay, good. 0.02. Good. Good. Okay, so I'll just rewrite this. This is 0.02 equals 1/2 to the t over 8.1. Now again, if the exponent is not the unknown, you're not using logs. You don't have to. You just calculate it. Okay? But in this case, this is the only way to get that down. Right? We can either get it to the third level, or we can change it to exponential. Logarithm, it is an exponential. So logarithmic would be log, what's the base? 1/2 to the 0.02 equals t over 8.1. Okay? And to do this, so it would be 8.1 log 1/2 to 0.02 equals t. Okay? So that would be the exact answer. And again, you get t to be 45.715 ... So I would say at 45 days, it's not at 2% yet. So the nearest day that it would be safe to go would be to the nearest day again, it asked, 46 days. Okay, that's how long. We did. It was 5.48. So I went to 5.5, which even rounding rules would have put me there. Yep. No, they will say when would be to the nearest day, when would it be safe to go back? No, not always. You know what? You'd have to, I would test it. I'd put it back in. So what I would do is I would put 45 in here and 46 in here and see if it gets to where, see what my answer is. That's the best way to do it. Mm-hmm. Okay, so instead of this one, I did this one with the other class, and it's quite easy. Let's just actually fill it in without even finding the answer. Use the formula, there it is. C is 1/2. How many years for the isotope? It was initially to be present to decay to 60 grams in 14 years. Okay, so do I know, what do I know? Sorry? 14. Okay, why would I say it's 14? It doesn't say that it halves in 14 years, because then it would be P. But it does say it halves in 7 years, right? So this would be, P would be 7, T would be 14, C would be 1/2, A would be 60. And it's A naught we're looking for, right? So let's just write that. 60 equals A naught. 1/2, so 14 divided by 7 is 1/2 squared. So 60 equals A naught times 1/4. So what's A naught? 240 equals A naught. So this one, you do not even need logs or anything. Okay. So I think it would be awesome if Wednesdays are good days to have no homework, right? Because it's kind of like, yeah, every day is good, but you know, Friday is the best. Yeah, but Wednesdays aren't bad either. Okay. So again, we have more time than the last class. There should be tons of you that get it done in class. Also, at noon, because I'm going to try and get them done by the end of this class, which I should be able to at noon, your marks should be up on School Zone. I need you to check them very carefully. I don't want mistakes left to the end of the year. I need you at today to go there, check that your homework mark, that is accurate.